Hello all. So now we are going to get familiarized with a very common practically used operational amplifier known as IC741. So this is an IC which is termed IC741. Now I'll show you the pin diagram, or actually the IC here. This is the IC which you see in the lab, IC741, with totally 8 terminals, 4 terminals on this side and the other 4 terminals on the other side. And this is the pin out diagram of IC741. Okay, so first we shall basically understand what are the different pins meant for. Now, how to count the pins of IC741, any IC. What you have to do is you keep the IC in such a way that you see the depression here. There is a darkened depression you can see here. There's actually a depression on the covering, and then from that, if you keep in this orientation, and from the left of that you start counting as the first terminal. So this is not the other first terminal, this is the first terminal. Okay. If you are keeping IC on your hand, you keep this one on the top side and then start counting from the left. So left, the top one, very near to this depression. To the left hand side, which you see, that is the terminal 1, the 2, 3, 4. Then you have the other side 5, 6, 7, 8. So this is how you count the IC terminals. Now what we have to understand is what is this terminal 1, 2, 3, they are all meant for what purpose. You cannot connect terminal 1 as you want to any of the leads. It is not possible. It will not function and the IC will get damaged. Each terminal is meant to do a particular task. Okay, now you come here. You have here the terminal 1. It is given it as offset null. That I will tell you later. Then you focus on terminal 2 and 3. So terminal 2 and 3, you can see that 2 is terminal meant for the inverting input. So if you want to connect the op-amp in an inverting configuration mode, or you want to give a signal at the inverting terminal, you have to give it at the terminal 2. So terminal 2 is, in the case of IC741, is meant as the inverting input terminal, and you have terminal 3 as the non-inverting input terminal. So if you want to connect the op-amp in a non-inverting mode, you have to give the signal at the third terminal. Okay, so terminal 2 and 3 is meant as inverting input and non-inverting input terminals respectively. And that is why here it is shown as the negative, because you give a signal at the inverting terminal, you will get the output in the inverted form. That is why you term it as an inverting terminal. Then you have 3 as the non-inverting, shown in the plus signal form. Then you have the output, right? So you give 2 inputs in signals at the inverting and non-inverting terminal, or in whatever terminal you want. Then you will get an output. That output is actually given internally, and it is shown here op-amp. So the 2 inverting non-inverting leads is given to the op-amp, and then the output is given to the op-amp is given to the output 6th terminal of the 741 IC. So if you want to get the output, that you have to get from the 6th terminal, 1, 2, 3, 4, then 5, 6. Will have a terminal here, your lead here. From that you can get the output. So that is the output terminal. Then you know that it requires supply voltages, right? So we normally show here a plus VCC and minus VCC. So you have to give this terminal a plus voltage, plus supply voltage, positive supply voltage, and here you have to give a negative supply voltage. So that leads are connected to the 4th and the 7th terminal of the IC. So you can see this positive terminal connected to the 7th lead of the IC, and the negative terminal or negative supply terminal, it is connected to the op-amp is connected to the 4th lead of the IC. So what you have to give? You have to give the 7th terminal of the IC a plus positive voltage. Like in the case of IC7, mostly we give a positive 15 volt. So that this positive plus 15 volt should be given to the 7th terminal, and the minus 15 volt should be given to the 4th terminal. Okay, so the supply voltages are okay given. Now actually this 8th voltage is not connected anywhere normally in practical case, and then you have the 1 and the terminal 5. They both are denoted as offset null. You know that about the output offset voltage, because you give, even if you don't give any input signals at the input terminals, you practically expect a very small voltage at the output. Okay, that voltage is what we call as the offset voltage, output offset voltage. It is because of the actually variations in the transistor, or because you give all the biases and all, there is, even if you don't give any voltage, there is a voltage difference existing at the base of the two transistors, and these bases are which we consider as the inverting and non-inverting terminal. So there is a small variation in the voltage which is of the order of very small nano or more microvolt range. So that voltage is existing at the input leads. So this, because of this input offset voltage, even if you don't give any additional signal voltage, you will get an output voltage, right? So that is what we call as the output offset voltage. But for a fair working of an IC or op-amp, you want most of the time you may want to nullify that output offset voltage. So you can give an input at the input leads, or in the op-amp you can give additional voltage in order to make the output voltage forcefully zero. So I hope you understood that you can make, or in order to forcefully make the output offset voltage zero, you can give an additional voltage in the op-amp circuitry, so that we can forcefully make the output offset voltage zero and make it perfectly output offset voltage, that is and make the output offset voltage zero. And this can be given, or IC741 as an additional feature, that if you can give additional circuitry between the voltages or between the leads 1 and 5, you can fairly make the output offset voltage zero. So actually 1 and 5 leads are used to offset or nullify the output offset voltage. Understood? So leads 1 and 5, they are used to forcefully nullify the output offset voltage. So that you will learn in the higher classes how you give the circuitry between 1 and 5 in order to set the output offset voltage zero. But anyway, you understand that 1 and 5 leads are used to nullify the output offset voltage. So now we understood every terminal of IC741. Leads 2 and 3 used as inverting and non-inverting terminals. Leads 4 and 7 are used for negative and positive supply voltages. Then lead 6 is used as the output terminal. Then terminals 1 and 5 are used to nullify the output offset voltage. Then 8th terminal is normally not used, and it is since it is not connected, it is termed as NC. So this is about the pin out diagram of an IC741. Now I'll tell you one more thing about the supply voltages. Here you can see an op-amp is connected, and op-amp circuit symbol is given, and then you have the plus 15 volt connected here, but nothing is given here. You have plus 15 connected here, minus 15 volt connected here. We call this a single supply op-amp because you know that there are two leads which can be connected to the positive and negative supply voltage. So, but then it can also be used in such a way that you give only one of the supply voltage, that is you can give one a positive 15 volt here, but you don't give anything in the negative terminal or in the negative or at this terminal, you can ground it, make it grounded. So you are giving only single supply. So there are op amps which are used in this way, or you can make it the other way as well, right? That is, you can give here negative 15 volt and you kept here grounded. That also is possible. Okay. So either way, a single supply voltage can also be given in certain op amps in certain instances. Okay. Then split supply voltage means that you give both positive as well as the same negative voltage on these two terminals. Okay, so that is in the case of IC741, it is at the terminals 4 and 7, right? But anyway, I'm talking now about the general op amp. So here we normally use a dual variable supply because you have a plus 15 lead as well as a negative 15 lead. You give the plus 15 here and negative 15 here to this lead. So this is split supply mode, and it can be given in this way also. So depending upon the op amps, depending upon the various methods we connect, you can have single supply as well as split supply voltages given to the op amps. Now one more thing, the supply voltages basically determine the output voltage. It gives a restriction to the output voltage. It means that you cannot have an output voltage greater than this plus 15 volt. Okay, so this actually plus 15 volt supply voltages give a restriction on the output voltage. You cannot get an op amp output voltage greater than this plus 15 volt from this op amp. In IC741 also. That is, if you, it is not like sensible when you say that you give a voltage of 15 or you give a voltage of say very high voltage at the input side, and because you cannot, output offset voltage cannot be made greater than plus 15 volt. So it means that it will be, if it is the output offset voltage will be greater than 15, you will get a clipped output voltage. So this gives a restriction on the output voltage. So that means that you cannot, so if you give a voltage in the microvolt range, depending upon the range, you will get a fair good voltage. So open loop configuration, the gain is, you know that the gain is very high. It is of the order of 10 raised to 6. So even if you give a voltage of 1 volt at the input side, that is, if I give input voltage Vi as 1 volt, the output voltage which you are going to get is 10 raised to 6 times 1 volt. Okay, so that is not open loop configuration. In open loop configuration, this is the gain, but you cannot get a voltage greater than 15 volt. So it is not sensible to say that I give a 1 volt input signal and you get a high gain, but that high gain will be restricted by the supply voltage. That also we should always keep in mind. But if I give say 15 microvolt at the input side, so then I can say the output voltage is 15 into 10 raised to minus 6 into 10 raised to 6 is the gain. So then you will get a 15 volt. So if 15 microvolt voltage if you give as the input, then you can get a 15 volt fairly good, because 15 after 15 volt, but above 15 microvolt if you give an output input voltage, the output voltage will be clipped. Okay, so that you must keep in mind. But this whole thing will change when you give a feedback connection, because gain is going to reduce when you give a feedback connection to the circuit. So I hope you understood. So in this video we were discussing about the different pins of IC741 and what each pins are specifically used for. Then we also discussed about the supply voltages used in op amps. So thank you very much.